DePIN is not one market. It is a coordination model applied across real infrastructure: wireless, compute, storage, sensors, mobility, and energy. As we move through these categories, keep three questions in mind: who supplies the assets, who demands the service, and what real utility is created. So far, we've built the foundation. DePIN combines physical infrastructure, decentralized coordination, and token incentives. We also covered why the timing matters now. Next, we shift from the what and why to the where, the major categories where DePIN is being applied. A useful way to compare DePIN networks is to ask what physical resource is being supplied, who needs it, and how the protocol proves the work happened. Wireless, compute, storage, data, mobility, and energy all look different, but the pattern is similar. Contributors provide capacity, verification filters out fake or low-value activity, and rewards should follow real demand. The strongest networks are not rewarded simply for installing hardware. They create value by delivering useful infrastructure. Wireless DePIN turns connectivity into a community-deployed network. Instead of one telecom company funding every tower or access point, local contributors install hotspots, CBRS radios, Wi-Fi access points, or small cells. The protocol verifies that useful coverage exists, and then devices, mobile users, or enterprises consume that coverage. Tokens can help attract early supply, especially in underserved areas, but long-term value depends on real demand and usage fees flowing back to the network. Early wireless networks often reward people for installing hotspots before customer demand is fully proven. That can expand coverage quickly, but only if the network confirms the hardware is real, in the right place, and transmitting a useful signal. Proof of coverage supports this through location checks, radio tests, peer challenges, and attestations. Reward design matters. Pay for verified, valuable coverage, not just more devices, or the network invites spoofing, ghost hotspots, and oversupply. Decentralized wireless is not one single model. Mobile coverage uses small cells or radios to extend service, where carriers have weak reach or need more density. Wi-Fi offload shifts traffic from cellular networks onto local Wi-Fi, easing congestion and lowering delivery cost. Community telecom goes further, with local groups owning infrastructure designed around local needs. Across all of these models, the key constraint is integration. To become useful at scale, they must work with devices, carriers, roaming systems, and regulators. Compute networks turn unused or specialized hardware into a shared marketplace. Providers contribute GPUs, servers, data centers, or edge devices. Customers submit jobs such as AI training, rendering, research simulations, or Web3 workloads. The network matches each job to suitable capacity, coordinates execution, verifies results, and triggers payment. The challenge is not just finding machines. It is delivering reliable performance, low latency, security, and proof that the compute was actually completed. Within compute, GPU networks concentrate expensive hardware for demanding workloads like AI inference, fine-tuning, rendering, and simulations. Edge compute pushes smaller, distributed resources closer to devices and users, which matters for IoT analytics, autonomous systems, gaming, and localized AI. In both cases, customers are not buying abstract decentralization. They are buying uptime, throughput, low latency, memory, networking, and usable developer tools. Verification remains the difficult part, proving the work was completed correctly, efficiently, and reliably. Storage DePINs are not just decentralized hard drives. They solve different persistence problems. File storage is optimized for active user and application data, where retrieval speed and cost matter. Archival storage prioritizes years of durability, redundancy, and proof that data has not disappeared. Data availability is more blockchain-specific. Participants must confirm that transaction data can be accessed and verified. Across all three, the core question is the same: can the network keep data available, prove it, and retrieve it on demand? Sensor DePIN networks turn everyday locations into data collection points. A weather station on a roof, an air quality sensor near a road, or a device in a vehicle can feed real-world signals into a shared data hub. These networks are most valuable where centralized measurement is too costly or too thin. But buyers only trust the data if devices are calibrated, accurately located, consistently online, and protected against tampering or fake submissions. Mapping DePIN turns everyday movement into map infrastructure. A driver, phone, drone, or dedicated vehicle captures imagery, road conditions, traffic signals, and points of interest. The network checks when and where the data was collected, compares it against other submissions, and filters duplicates or manipulation. Once validated, the map can update faster than a centralized survey cycle. Fresher data can support navigation, logistics routing, urban planning, autonomous vehicles, and location-based services. Mobility DePIN treats transportation as a moving data network. Cars, scooters, trucks, parking systems, and traffic infrastructure can generate signals about road conditions, usage, location, and availability. The network coordinates that data, verifies contributions, and makes it useful for navigation apps, fleets, city planners, and logistics providers. The barriers are not only technical. Adoption also depends on hardware access, driver consent, privacy controls, and partnerships with platforms that already sit close to mobility demand. Energy DePIN turns many small energy devices into coordinated infrastructure. An EV charger, home battery, solar array, or smart thermostat can provide value when its status is measured, verified, and matched to demand. Drivers get more charging access, grid operators get flexibility, and asset owners can earn rewards. Here, the hard part is not just software. These networks must work with utilities, meters, regulation, and local grid limits in the real world. Across categories, the coordination pattern is similar, but the constraints are very different. Wireless and energy depend heavily on location, regulation, and real-world deployment rights. Compute and storage can scale more globally, but customers expect strong performance and reliability. Sensor, mapping, and mobility networks win only when data is dense, accurate, and trusted. The best opportunities connect token rewards to real demand, not just supply growth. DePIN is not a single market. It is a set of infrastructure verticals connected by decentralized coordination. When evaluating any category, ask, is demand real? Is supply useful? Can the work be verified? And can operations stay reliable? Next, we turn these checks into a market map.